Okay, now we will try to solve some numerical and theoretical question from BARC 2026. So first question is, if a 2 by 2 matrix M our eigenvalues are iota, twice iota and minus twice iota, then the matrix will be. So here we can see that the eigenvalues are purely imaginary. Okay, so iota, twice iota and minus twice iota. So here eigenvalues are purely imaginary, therefore the matrix M must be an anti-Hermitian matrix. Okay, so option C will be the correct one. Next question is, Hamiltonian is given for a particular system. Hamiltonian is given, then we have to find the actual eigenvalues of Hamiltonian H. Okay, so this is the form. So if we want to write the Hamiltonian in matrix form, then what will be the form? Now the form will be H equals to E naught times, so this is the position of phi 1, that is outer product. This is called the outer product, and inner product is this. So this is the inner product and this is the outer product. So this is the position of phi 1. So coefficient of phi 1 is class 1, so we put 1 here. Okay, secondly, this is the position of phi 1 phi 2, so coefficient of phi 1 phi 2 is 1. Again, for phi 2 phi 1, the coefficient of phi 2 phi 1 is plus 1. Okay, and again the phi 2 coefficient is minus 1. So this is actually the Hamiltonian matrix. Now we have to find out the eigenvalues of this matrix. So H is nothing but E naught, E naught, E naught and minus E naught. The general way uh, we used to find the eigenvalues of any matrix is that is determinant of H minus lambda I. Determinant of this must be 0, so lambdas are the eigenvalues for the corresponding matrix. So what will be the exact form here? That will be E naught, I is the identity matrix, E naught minus lambda, again E naught here, E naught, and here it will be minus E naught minus lambda. So we have to find the determinant of that whole matrix, that equal to 0. Okay, this is called the characteristic equation. So from here we can find that if we take negative sign for this term common, then it will be E naught minus lambda, E naught plus lambda and minus E naught squared, that will be 0. So this is nothing but A minus B into A plus B. So minus E naught squared minus lambda squared minus E naught square. So here minus E naught square, here also minus E naught square. So it gives minus twice E naught squared plus lambda squared, that will be 0. So lambda squared will be twice E naught squared. So lambda will be, since it is 2 by 2 matrix, so obviously there will be only 2 eigenvalues. So it will be plus minus root 2 E naught. Okay, so eigenvalues of this matrix, of this H matrix, Hamiltonian matrix, will be plus minus root 2 E naught. Okay, so option B is the correct one. Okay, next question 3, that is from the contour integral, from the complex integral. So here we have to find out that integral of sin z divided by z to the power 4 dz. Okay, what is the value of integration sin z divided by z to the power 4 into dz? So here we use the complex integral, that is the residue theorem. So first of all, yeah, this is f of z. Okay, so, so according to residue theorem, integration of f of z dz, that is nothing but twice pi iota into residue of f of z. Okay, at that point which are inside the contour. Okay, so here contour is not mentioned, so basically only residue. Okay, so if we have a single function, then we just take the residue of that function. That is, what is the residue? Residue is nothing but the coefficient of 1 by z, okay, or z minus a naught to the power minus 1. The coefficient of this term is called residue. So basically here our f of z is nothing but sin z divided by z to the power 4. So we can expand that trigonometric function, that is sin z. Then we can after that we can easily find the coefficient of 1 by z. So here f of z is nothing but f of z is sin z divided by z to the power 4. Fine. So 1 divided by z to the 4. Now what will be the sin z? Expansion of sin z is nothing but only the odd power of z will exist, okay. So z minus z cube divided by 3 factorial, then plus z to the power 5 by 5 factorial, and minus so on, okay. So now multiple with 1 by z to the power 4 with each term, so it gives 1 divided by z cube minus 1 divided by 3 factorial into 1 by z, again plus z divided by 5 factorial, and minus dot 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 dot, okay. So here we have to find the residue of f of z, that function. So what will be the residue here? So residue, we know that residue is nothing but the coefficient of 1 by z, coefficient of 1 by z term, or z to the power minus 1 term. Or since here we can see that z equals to 0 is that is here, since sin z divided by z to the power 4, so z equals to 0 is the pole, that is the pole of order 1, that means it is simple pole. So it expand, sin z divided by z to the power 4 expanded about z equals to 0 point. So obviously we can see that the coefficient of 1 divided by z minus 0 term is nothing but minus 1 divided by 3 factorial. So that will be the residue for this function, okay. So that will be the residue for this function. So here we get the residue of this function is residue of f of z at z equals to 0 is nothing but minus 1 divided by 3 factorial. So that is minus 1 divided by 3 factorial is nothing but 6 na. So minus 1 divided by 6, this is the residue. So according to residue theorem, what will be the integral of this function? So integration f of z is nothing but sin z by z to the power 4 into dz is nothing but twice pi iota into residue. So residue is minus 1 by 6, so it gives pi iota with a negative sign by 3, okay. So the answer will be option B. Fine. Next question is question number 4. The Bose-Einstein condensation. In Bose-Einstein condensation, the critical temperature Tc depends on mass of the boson. Okay, how? Variation. What is the variation between Tc and mass of the boson? So here you have to remember the variation, because there is a formula between this Tc with m, okay, and there may become the zeta function like that. So it comes from the advanced statistical part. So if we see that the exact formula of Tc, exact formula of the or exact expression of critical temperature in case of BE statistics, so you can see there is a variation between Tc and m. Tc varies with m inversely, okay. So Tc proportional to 1 divided by m. So the option will be A option will be the correct one. Here maybe maybe it will be zeta 5 by 2 or zeta 7 by 2, like that, okay. So you can read this portion, okay. Next question, question number 5. One configuration is given, okay. There is a triangular shape, so minus 2q charge is placed at origin, plus q charge is placed at -1 0 point, and again plus q charge is placed -1 0 point. Okay, now we have to find out the dipole moment as the whole system. Okay, dipole moment for this whole system or for this configuration. So what will be the dipole moment? So first of all we have to check that as a whole, if we add the whole charges in the system, uh, if the addition of whole charges of the system gives 0, okay, then we can we can simply write the dipole moment for this system is nothing but summation of qi ri. Okay, ri is the position vector corresponding that charge. Okay, so it is applicable only when the summation of qi gives us 0. Okay, so we have to check whether the summation of qi, all the addition of the charges gives 0 or not. So here in this configuration there are three charges, -2q, plus q, and again plus q. So addition is nothing but -2q plus q plus q, so it gives 0. So we can easily use this formula, that is the dipole moment for this system is nothing but summation of qi ri. Okay, so simply let's find. So for -2q charge, -2q into the position vector is nothing but 0 0 0, that is 0 I cap, 0 j cap, 0 k cap, so ultimately 0. So 0 I cap plus 0 j cap plus 0 k cap. Find second one is plus q at -1 point, so minus I cap minus j cap, and for k is 0. And third charge is q at +1 -1, so I cap minus j cap. So ultimately you get minus I plus I are cancelled, so only minus j, so it gives -2q j cap, -2q j cap. So this is the dipole moment for this configuration, -2q j cap. So option A will be the correct one. Okay, next move to the question number 6. So there are three half spin particles, okay, are placed on 1D infinite potential well. Width is given A. Then what will be the ground state energy? Okay, so first of all spin is half. So if spin is half, what will be the occupancy number? That means how many particles can occupy in a single state. So that is nothing but twice s plus 1. So spin degeneracy is what? Do half, so 2 into half plus 1, so it gives 2. So we can put two particles in a single state. Okay, so there are three particles. Okay, so number of particles is 3. So if we have, this is the state 1D for 1D infinite well. So let's take consecutively two state. First, this is the according to the simple form for a single particle, this is the ground state, lower state, and this is the first excess state. Fine. Okay, now what is the energy expression for this system 1D infinitesimal potential well? That is n squared, sorry, n squared pi squared h cross squared divided by twice m a squared. Okay, so this is the state ground lower state n equals to 1, this is the n equals to 2. So for n equals to 1 it will be pi squared h cross squared divided by twice m a squared, and for the n equals to 2 state it will be n squared, that is 2 squared, 4 times pi squared h cross squared divided by twice m a squared. Okay, now we have three particles. So we have three particles, and there is a restriction that we can maximum we can put two particles in a single state. So we can put here one particle and here one particle, that means two are placed, but we have three particles. Okay, so one is left. so we can put another particle in the again the lower state, because the occupancy is what? Occupancy is 2. Okay, now we have to find out the ground state energy. So ground state energy, that means we have to build the lower energy configuration. That's why we put the third particle in the lower state. If we put third particle in the higher state, that means n equals to 2 state, then that does not indicate that the lower energy configuration, then for that system we cannot find the ground state energy. So that's why we put here the third particle in the lower state. Okay, fine. So what will be the total energy for this configuration? Two particle in the lower state, corresponding energy is this, and one particle is here. So ultimately for this system, what will be the ground state energy? That is 2 particle in this lower state, so 2 times pi squared h plus squared divided by twice ma squared, plus 1 times 4 pi square h plus square divided by twice ma squared. So it gives 6 times pi h plus squared divided by 2 ma squared. So it will be 3 times pi squared h plus squared divided by twice only ma squared. So option C is the correct one. Okay, next question number 7. So in question 7, a matrix is given, 2 by 2 matrix is given in form of sin theta cos theta minus sin theta. Fine. Now we have to find 2 sin a. Okay, 2 sin a. What will be the 2 sin a? Okay, so see, sin a, what is the sin a? If we expand sin a, we can find that a minus a cube divided by 3 factorial plus a to the power 5 by 5 factorial minus dot 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 dot. Okay, so this is the a. So if we take the a squared, that means a times a. So if we do a times a, then it gives sin square theta plus cos square theta. So it will be 1, fine, and sin theta cos theta minus sin theta cos theta 0, 0 and 1. That means it gives the identity matrix. So again, if we take a cube is nothing but a into a squared. So a square is, since a square is identity, so ultimately a cube is nothing but a. Fine. Okay, so we need this relation to solve this question. So fine, so if we common out a here, then it gives I identity matrix minus a divided by 3 factorial plus a, it will be a to the power 4. Okay, a squared here, a to the power 4 here, and 5 factorial and so on. Now a squared is nothing but what? Identity matrix again. A to the power 4 also identity matrix, that means a to the power 2n term, that is only the even term, all gives us identity matrix. Fine. So here this is the series of identity matrix. Obviously this is the sign series. So ultimately we get a sin I. Okay, so ultimately we have that sin a is nothing but what? Sin a is a sin I. So 2 sin a will be 2a sin I. This will be the answer. Okay, option is not matching. Okay, not, this will be the correct one. Fine. Next, Hall coefficient RH for intrinsic semiconductor. Okay, so here the formula is given as, that is the RH is P mu H squared minus N mu E squared divided by E into P mu H plus N into mu E whole squared. Fine. So where mu are the mobility, so mu h is the mobility of hole, mu is the mobility of electron, n and p are the concentration of uh, uh, hole and electron. So in case of intrinsic semiconductor, we know that for intrinsic semiconductor the concentration of electron and concentration of hole are same, that is n and p are same. So n and p are same, so if n and p same, then the formula can be normalized. Okay, so after that we know that in case of intrinsic semiconductor the mobility of electron is always higher than the mobility of hole. So mobility of electron is always always higher than the hole. So if we put n equals to p here, then obviously the sign or positive or negative, the sign of Hall coefficient directly depends on the mobility of electron and hole. Since mobility of electron is higher than the mobility of hole for intrinsic semiconductor, so RH must be negative. So RH must be negative because of mobility of electron is higher than the mobility of hole. Fine, so option A will be the correct one. Question number 9, in a one-dimensional infinite potential well with this L, the force acted on the particle during the collision on the wall. So force is nothing but change of momentum, dpdt. Okay, so since momentum is direct, does not depends on L, so obviously force does not depend on L. So obviously the force is independent of L. So option B is the correct one. Next question number 10. So in three-dimensional density of state is given by this form, that is varies as e to the power n. So for electron system, considering electron system, what will be the n value for 3D case? So in general the DOS is varies with E like this, d divided by s minus 1. Okay, so what is s? S is nothing but S is what? S is we know that for electron the energy is defined as E is proportional to k to the power k squared. Okay, so here E proportional k to the power s. So here s is this. So power is 2. So for electron system s is 2, and for 3D is d is 3. So it will be e to the power 3 by 2 minus 1. So ultimately we get e to the power half. Okay, so this is the variation of density for 3D and for